Welcome to Maths IEC. Here's another exam style question on electricity A-level physics. Pause the video and give it a try. When you are ready for the answer, press play. The diagram illustrates a potential divider setup that includes a thermistor with a negative temperature coefficient, NTC thermistor, component X. As the room temperature rises, observe the resulting changes in the meter readings. Okay, so obviously as the room temperature changes, the voltmeter V1 and V2 readings will change. Choose the correct row in the table that indicates how the values on the voltmeters and ammeter change. Okay, let's have a look. Let's think what happens in each one. Now, personally, when I'm doing questions like this, I'd like to just think about what happens for each one and then just get the answer that way rather than doing trial and error with each one and to see which one fits. So because it's easy to decide what happens to each meter reading, get the answer, and then see which row is the answer, because the answers are pretty similar, so you don't want to get confused. Now, as the room temperature increases, the resistance of the thermistor decreases. Now, what that means is the EMF of this cell, right, is split between X and Y. The proportion of potential that is across X decreases. Therefore, the voltmeter reading here, V1, will decrease. Now, let me explain this with some numbers. You don't really need to think like that, but just to understand it better, you can do that. Now, let's say the EMF of this one is 10 volts, and say the internal resistance is 0, and this one is 2 ohms, and this one is 3 ohms. Now, initially, this 10 volts is split in the ratio 2:3. So, across the bottom one, for Y, we have 6 volts, 6 volts here, and 4 volts here. Now, the temperature rises, the resistance decreases. Say this 2 ohm now becomes 1 ohm. Now, this 3 does not change because it's a fixed resistor. So, what will happen now? Now, only 1/4. Why 1/4? Because the new resistor values are 1 and 3. 1 and 3 is 4. So 1/4 of 10 is 2.5. So this will be 2.5 and this will be 7.5 volts. And now you can clearly see it was 4 volts before. It becomes 2.5 volts now. So the voltmeter reading decreases. But if you just qualitatively think about it, the resistance decreases, so the PD across that decreases. So I know what happens to V1 now. And when V1 decreases, because the total input voltage is the same, V2 will increase. What will happen to the ammeter reading? Now, this is a series circuit. The current starts from here, goes through this, goes through this, through this, through this, through the ammeter, and comes here. The voltmeters can be considered as extremely high resistance, so there is no current going through that. Now, if you think about the total resistance of the circuit, that decreases. So, I is equal to E over R plus R. So, the total resistance decreases, EMF is constant, so obviously the current will increase. So, my answer is V1 decreases, V2 increases, current will also increase. So you can clearly see the correct option is C.